All righty, well, let's go ahead and get started so we're respectful of everybody who logged in on time. So first, thank you all for listening in today. I'll do a quick run through of our agenda. We will, of course, be starting out with some introductions. We've got some great panelists and just want to provide a little bit of an overview for the topic today. And then we will dive into our top 10 construction mistakes, which hopefully will be entertaining for everybody. And then towards the end, we're going to do something a little crazy. We have invited the audience, if they've got particular issues or things that they've come across, to volunteer those. We've got some of our organizers in the background that are going to be watching the questions. Since this particular presentation topic doesn't really have a lot of questions, we're going to use that instead to kind of volunteer ideas or issues you've run across, and then we will pick a couple of those, 3 to 5, and then actually make those individuals presenters towards the end of the webinar and let them share their own issues. So if you've got a really good juicy construction field error or issue you've run across and you want to share, go into the questions tool in the webinar and let us know. Quick housekeeping stuff, of course. We will keep everybody muted during the main part of the presentation. If you have to drop off, go to something else, or if one of your peers was wanting to be there and can't, we will be, of course, sending out a link to anyone that registered so that they can view the recorded webinar afterwards and relive the top 10 mistakes that we came across. So with that, do a quick introduction here. I am your host today. I'm the VP of Product Management here at ClearEdge 3D and responsible for both Edgewise and Verity Product roadmap and making sure that all of our wonderful customers have a line into the company to get their suggestions and requests prioritized and hopefully into the product. So I know we have a lot of our customers on the call, so thank you all, and be in touch. And then addition to, being on the software development side, I am guilty of dancing occasionally and playing the guitar. So if you catch me at a conference, there is a risk that I will have a musical instrument with me. So be forewarned. And with that, let's talk a little bit about the kind of context behind this topic. So, of course, we all know that rework is a big part of the construction industry that we all hate to love or love to hate. Industry surveys kind of indicate that it's somewhere between 5 and 12% of the total project cost is actually lost to rework, both in material and labor costs. So that's pretty substantial. And of course, our current workflow is really built around spot checking or selective checking, looking at individual things and making sure that they're correct, but not really being able to check most of the work that gets installed on the job site. And the good news is, of course, laser scanner prices are falling. There's new hybrid pieces of equipment coming out. And this is really kind of what prompted us to jump into this QA/QC market for construction and to start talking to our customers about some of the things they'd seen in the field. And ultimately, our goal is to provide solutions to all of you to go out and check all the work so that, we can all find these issues earlier, resolve them sooner, and, save a lot more money on our projects. So with that, let's talk about our fantastic panelists. So first, we'll start with Will Eichard. Will is the founder and principal, along with his wife, at Eichard Consulting, and so He has spent a lot of time helping other people with their projects when things go wrong, and so he's got a great example we're going to look at. Will, you want to say anything?
You know, one of my claims to fame is I've gotten to work with you for over 12 years throughout our careers, and always enjoyed it. And I also get to have the pleasure of being with the BIM Forum. I'm on the board of directors there, and have worked a lot on the LOD specification.
All righty. And next we'll say hello to Anton. So Anton is the Chief Operating Officer of VIATechnik, which is a services company for the BIM space, and interestingly swam with a saltwater crocodile. Anton, you want to say anything?
Yeah, I'm still alive. No, so I've lived in Asia, Australia, and the US, and definitely seen a lot of construction go on all those places. So I'm glad that I'm going to share some of the things we've seen, especially working with a lot of point clouds, and quite interesting issues that have come up.
Excellent. And then we have got two more panelists. So Buck Davis, who is a VDC Project Solutions Manager at Balfour Beatty Construction, who has the longest title of our panelists today, and loves to surf and has a 4-pound dog. Yeah, and you can't turn left, is that correct, Buck? You're not an
I don't go left. Also, man, I wanted to wish my mom a happy birthday. It's her birthday today, and I'm pretty sure she's listening on the webinar. So just want to give her a shout out.
Hello to all the proud parents. Excellent. And David with Baker Concrete Construction, a senior BIM VDC designer. And David actually has the distinction of bumping out our former #1 issue with one that he sent in 2 days ago. So yeah, David will be going last in our order of speakers with the Big Bang project. So
I just wanted to thank my wife Stacy for helping me kind of sum up some of the stuff. She was the assistant project manager on the second example part of mine, and also, just by happenstance, the rocket stacking building I listed here is actually on one of Buck's slides. I thought that was pretty crazy.
Yeah, you know, it's a small world. And now you two have actually co-founded a company together. So I guess that project went pretty well.
Yes, it did.
All righty. So with that, let's dive into the meat and potatoes. So starting out with our number 10 issue. Buck, you want to queue up here?
Yeah, I'm gonna queue up. So this is a couple years back. I was working as a consultant. I had gone and trained a general contractor for a robotic tunnel station rollout. I got a call about 3 weeks later, and they said they were having serious problems. They actually wanted me to come down and pick up the equipment, said it was broken. They were just having all kinds of trouble. So I find out the project's actually a launch pad. So I raced down there, got to the project site, got out there, tested the equipment. Everything was working fine, as always, in a trailer. Got out to the job site, set up, did some backsighting. Couldn't quite figure out what was going on wrong. The issue that they were having, and if you look at the launch pad, it looks like a perfect circle, was that as they got closer to the center of the circle, you know, the points started deviating in the wrong direction. They were going from about 3 inches to 12 inches, which was strange. Typically, when you have a robotic tunnel station that something's going off, you would be consistently wrong, not deviating wrong. So, you know, I spent a day out there with a surveyor. We couldn't figure out what was going on. I mean, the project team was sweating bullets. I mean, they had all but stopped working. If you're looking at this picture in the background, the launch pad had previously been for unmanned launches. So they were actually retrofitting it for manned launch, and they had a date coming up. So there was no pushing past the schedule, really. So the guys, you know, they started saying, take the robot, we're going to pull tape. And I kept trying to emphasize that there is no margin of error on a launch pad. You know, that their client, I can't name, was not going to tolerate a 1/2 inch or even 6 inches off. So I was sitting talking to one of these old veteran engineers on the job site, taking a break from it right before I was about to get thrown off the base. And you know, I said, this circle's just beating me up. You know, I can't get anything to line up. Nothing's working. And he said, well, that's because it's not a circle. It's ellipsis. It has a 1 foot bump north, which is throwing you off. And immediately it made sense. As we got closer to the middle, you know, we were pulling 12 inches in the wrong direction. So I went back in, jumped in the computer, stalled it when they exported their points. Instead of northern easting, they did easting northern. So it wasn't a dramatic change because it was practically a circle, but it was enough to throw everything off. I think they had been down and actually not working for about 7 days. And trust me, I was in a hot spot. Made the change, got back out there, and everything started lining up. You know, I think the one thing that I like to emphasize on this one, being a project solutions construction manager, is a lot of times people put down the tools because it's not working. Typically the tools aren't wrong. Either you've put the wrong data in, or you have something else going on. But this is not one of those things. You know, when the total station is measuring accurate, and I can show you that it's measuring accurate, something bigger is going on. So I thought this was a great example of, you know, believing in the equipment and still trying to find that problem. Everything works well in an office. When you get out to the job site, you know, a lot can go chaotic, but this was a time where that tool saved me, and I think it saved the project from everything that I saw.
The other thing I love about this example is that it's a classic case of, we always, you know, make a lot of assumptions going into a job, and a lot of times those assumptions we forget to check them, like the fact that this wasn't actually a circle, and those things can really trip us up down the road. So thanks for that, Buck.
Completely. Thank you.
Now let's take a look at number 9 here. So this is one I'm going to present for somebody that couldn't be here today. This one was something that we found early on during our testing on Verity. It was a pretty big steel job, checked about 500 different steel members, and we came across this one element, and it was very odd because, you know, the model was of course showing in purple there that it was supposed to be a sloped steel member, and the laser scan was showing that it had been installed perfectly flat. And yet the steel beam on the far end of it was installed at the right elevation. So it was kind of odd. And we started digging into this, and as it turns out, the architect had noted a slope on their drawings, but the structural engineer had not picked that up and noted it on theirs. And the subcontractor pretty much just looked at the structural drawings, put everything in, you know, this job was about a day and a half away from pouring concrete, but because this got caught ahead of time, you know, the cost was really minimal. So it's really only about $5,000 total cost just to go out there, you know, cut some steel out, put a new piece in. There were just a couple of sloped members. You know, but the project team was saying if, you know, they had found out about this 2 days later, it would have probably been a $25,000 to $50,000 cost to fix. So this one I thought was really interesting because it really illustrates how critical timing is when it comes to finding issues. You know, the difference of 2 days can, you know, increase the cost by an order of magnitude. So this one was kind of a fun one. And, you know, the takeaway here on the project was, aside from consistent documentation is always nice, you know, catching things early by doing these kind of holistic quality checks really did make a big difference, because they never really, you know, had an idea how much it would have cost if it had been wrong, when they would have caught it if they hadn't caught it now, or also schedule impacts that, you know, are not in those numbers. So, all right, and now let's take a look at our number 8. So Anton, tell us about this bridge expansion joint.
Yeah, so this is an interesting example where even modeling something in 3D for such a simple structure would have been very useful here. our client worked on a simple bridge span over railroad tracks, and there was the joint detail was all they gave for the joint detail was this image you see on the screen, and there were no elevations. So this is a plan view joint detail. The client kept requesting, sending RFIs like, how do you want us to build this? We actually can't visualize this. And the engineer just kept responding, see joint detail and reference this joint detail, build it this way. So if you go into the next slide, you'll see that the field couldn't really, didn't really know what to do, but they built this detail, and there were as-built conditions on the back wall. So the field just interpreted, created their own interpretation of this detail. The inspector actually approved the results because he looked at the joint detail in the drawings and said, "Yep, this is what the drawing looks like." As a result, actually, the only time that this was caught, and this happened in all 4 joints. If you go to the next slide, the only time this was caught was when the State Department of Transportation looked at it and said, like, "What you guys do here?" And there's a whole chain where they showed, everyone kept saying, "See RFI, see this joint detail," and they built it based on how the field thought, they built it. And unfortunately, it caused like all this delays, and the owner said, "No, this is not acceptable. You're gonna have to redo everything." So a simple 3D model, it would just save everyone all this time if they showed what the issue was.
All right. And then actually, Anton, you're up next as well. So this one is a classic case of tool mistrust as well, and with our favorite 3D coordination scope of work on our duct work, right?
Yep. So and it's a VDC services firm. We spend a lot of time working coordination, and we spend months doing coordination. I'm sure the audience members have a lot of examples too, where the field simply doesn't believe in the coordination process or thinks they can get ahead of coordination and do things faster than this VDC coordination process. This was even way more interesting in the sense that the superintendent and the project manager of this job was actually in the BIM coordination meetings, but at the same time, we weren't aware they were actually ordering ducts and having ducts fabricated based off of the design drawings. So, we're spending months in coordination, get everything class free, and we find out they're installing ducts based off of design drawings. So all the ductwork was ordered and prefabricated, not off shop drawings, not even off of approved shop drawings, just pure design drawings. If you go to the next slide, you'll see, some of the issues there where we, based on the BIM and, part of the contract required using point layouts to lay everything out to sleeve all the walls. And now, we're looking at all the ducts that have been installed. The result of that is now we're scanning all the ducts, getting all the existing conditions into a BIM, re-coordinating the entire job around the existing conditions, around the existing ducts. And now we're coring walls. It's just creating a nightmare. So all our 3 months of coordination is pretty much going down the drain. We're having to re-coordinate around the existing ducts, coring walls. It's just crazy. So I'm sure, this has happened. I'm sure this is probably happening in other jobs too, but there's a lack of trust in BIM, but then at the end of the day, virtual design construction works really well with complex projects, and there needs to be a better way to ensure people who are running these jobs just put their faith in the BIM process.
Yeah. Well, the other thing I love about this example is it basically, by ignoring the BIM and installing one scope of work just kind of completely differently, They basically took a new construction job and turned it into a renovation job in terms of their coordination complexity, and it's just like that's a great way to shoot yourself in the foot.
Oh, it's
Anton, was
brutal.
one of the reasons they did that to ostensibly save money and schedule by getting ahead of things?
We actually don't know, because we, to this day, we're baffled, right? Because the BIM process was on schedule. Everything was on schedule. And it just baffled us why they would go ahead and order things, not even from shop drawing. They ordered things from the design drawing. Did not make sense at all. We were just all like looking at each other and why did you guys even do this?
My goodness. Good example.
Yeah. All right, and so we're going to take a look at number 6 here, and number 6 is definitely the kind of issue that could have gone much worse than it did. So there's this was for a central utility plant for a hospital, and there've been a number of these things that I've had the privilege to look at and see over the last couple months, but this one kind of struck me because you had a bunch of really smart guys out in the field that were kind of field routing and putting stuff in place in a way that made sense. You can see here in this image the laser scan of where the pipes got installed versus the model of where those pipes were supposed to get installed. And if you kind of looked at it, they actually did a great job of significantly reducing the linear footage of piping that they had to install. But the effect of it was they basically mirrored the position. These kind of valve gates were all rotated 180 degrees, and this happened in several places throughout this central utility plant. And while I think one could argue that the solution they came to in the field was a better solution, they never documented it into the as-builts. And they never really informed anybody that they were doing this. And the challenge is those valve gates, they control basically water supply to different parts of the building. And you're in a hospital, and you certainly don't want to accidentally turn off water to the operations the operations rooms instead of the cafeteria, or vice versa. So these are the kind of issues that seem, pretty minimal, but if they don't get caught, you can have really bad outcomes as a result. Good news is, the contractor on this job was testing out some new tools. They found this issue that had initially been missed by both the spot checks and the commissioning, actually. But they found this well before handover, and they basically had to remobilize that subcontractor's CAD team to come out and redocument what was actually installed so they could turn over accurate as-builts to the client. So not an insubstantial amount of labor costs there, but nonetheless, this is one of those things that, everybody doing their job, spot checking things, people trying to do the best for the client, still had some pretty critical stuff fall through the cracks and not get documented correctly. All righty. And now, Anton, we'll pull you up here one last time for this one. So this is another as-built story.
Yeah. So and I'm sure a lot of people in the audience have seen this, where they look at the as-built drawings and every doesn't show much. It says, okay, this is the as-built, this is what to expect. It's usually always incorrect. So this project was a hospital renovation. The original building was probably done in the 1930s. So low ceilings, very tight plenum spaces, and it's in California. So you have room for seismic bracing and all these things. The last renovation was done in 1990. So 20-25 years later, they're trying to do a renovation. Actually, the owner was very progressive and said, okay, we should do laser scanning. We should get the as-built conditions of this space. But they actually decided to do the laser scanning after the design was complete. So if you go to the next slide, you'll see this hallway here, which is empty in the electrical as-built drawings. On the next slide, you just have all these conduits running through this hallway, and the designers actually put a lot of stuff into this hallway that they thought was empty. And you know, when the laser scan came back, we're like, hey, this is not going to work. The challenge there was that the design had to be pretty much redone. Over 100 RFIs were issued on as-built, and given that this is a existing hospital that's in operation, a lot of things could not be shut down or relocated because they were in use. So it significantly delayed the whole process. And then I think if you take a look at the next slide, the issue there was with all these existing conditions, it would have been much, much better for the owner to have requested the laser scan be done before the design was completed, right? Because by the time the contract was awarded to the GC and the GC's laser scan, the designers are pretty much checked out, right? Their team has moved on to a different project. So every time they respond to an RFI, they have like 15 days to respond or something. And we had over 100 RFIs because nothing was fitting. Places where they were putting ducts were just jammed with conduits, storm lines, etc. So one thing we've learned here, and we tell our clients often, is scan before you start the design process, so your designers understand what's going on and can plan for, shutting down services if necessary at some point.
That's a great example, Anton. And I think this is one of those challenges, is that we kind of get into this loop within the industry, particularly on renovation jobs, where we're dealing with incorrect information. We get frustrated. We kind of work through the project and get done, but sometimes are not aware of the irony of the fact that we are then handing over incomplete information to torture the next general contractor or subcontractor who inherits the job from us. So definitely something that happens a lot.
Yeah, exactly right. Because once the chain of responsibility moves on to the next person, it's a lot harder to get that other party to participate and be involved.
Yep. All righty. Buck, you want to pop back up here and talk about a really interesting movie theater screen? I think you're muted, Buck. All righty. Well, what we'll do is hop on to issue number 3 here, and maybe we'll come back. I'm guessing Buck's having a little bit of a audio drop out there. So Will, can we get you up to talk about your anchor rods here?
Certainly, and I'd like to thank Clear Edge for the opportunity to be here as well. This is a big issue. Everyone knows that you'll get invited to topping out parties on major projects. The general contractors understand this. You celebrate the completion of structure, and it's because nothing is formed on the enclosure until structure stands. No MEP hangs until structure stands. No interiors can be commenced until you get the building dried in, which goes all the way back to structure being that critical path. And in structural steel erection, one of the big problems you can have is when you delay the structural steel erection, you're holding up the entire project, and it has a ripple effect. You also have crane time. You have trades looking around at each other, waiting so they can commence their issues. And so one of the common things we see on projects is it could be something as small as the anchor rods, which are, in a structural steel project, it's probably one of the smallest pieces that go on there, but it's the critical link. And it really comes into this issue of cross-trade coordination with the concrete. And similar to some of the other challenges we saw earlier, it's crucial. You know, Kelly, you talked about the steel beams being misaligned, and if they caught that after the pour, how painful and expensive it is. And so if you looked at structural steel erection, we're going to look at some anchor rod examples here. What I have on screen is an obvious one. The steel detailer's model is shown in the green column, and then you can see where the concrete was actually cast and poured. Let's go to the next slide. This is another project, and what I want to point out here, this is a smaller job, probably had 30 to 40 columns, and as we look at it in the red circle there, those structural steel columns have been sitting there ready to stand for close to 3 weeks. Over half of the anchor rod placements were incorrect, and there was a number of areas where they were deficient. We can kind of go through some of those bullet points here. The anchor rods were horizontally off center. They were also vertically off, meaning they were skewed, and some were just plain missing. I really think a blind person could have easily seen the problems that you had with these anchor rods. And again, this led to the frame being delayed upwards of 3 weeks. We were called to do the laser scanning in the field. This project was probably about 6 hours from our job site, from our office is where the job site was. And let's think about the impact of this as we go through here. But first I want to talk about the process. So we have to identify the areas where there's the challenges, and we document the process we're going to do. In this case, we're laser scanning with a sufficient amount of density using a scan to BIM tool on it to do the extraction after we do the registration. And as we go into the next,
so shameless self-plug here, Will. What tool were you using?
This was Edgewise, and this one was a little while back. What we did is we actually modified the shape database for the pipe tables and used that to calibrate them to the common anchor rod diameters on this project, and then created an LOD 350 anchor rod model. And so if you go to the BIM forums level of development specification, you would note that 350 is for enhanced coordination, and that would be the level you needed to do remedial solutions. So within 1 business day, we had scanned and registered, and we're walking these details through with the client, and Ray Charles could have seen what needed to happen here once we had walked through each of these locations. This particular owner did not allow for torching of structural steel on site, and so what the team was faced with is shipping half these columns 6 hours away to the shop for fabrication. After the owner saw this and saw how well it was documented, we created remedial base plate templates, and we did get special permission on the project that allowed remedial plasma cutting of the base plates. And so probably about 90% of the columns were able to be modified, and in 3 business days, they were erecting steel again. And what you see on the image there is a layout where we mapped the design intent location of every anchor rod and then the installed. And what is so crucial in this is that it's not good enough to know the XY northing and easting location of the top of the anchor rod. You have to document how it is skewed, because the base plate has to slide down onto the rod. And so what you'll see in the ones noted there is they're actually elliptical looking, and that's because you're looking straight down at a skewed anchor rod, and that affects how you have to detail the remedial base plate details. This saved the erection schedule by getting it back on track. It also saved needing to throw away a number of the columns, and also the shipping cost by going back. So there's a number of savings here. And some of the big takeaways are, 1, hire better concrete trade contractors. Also, be a part of helping them be better trade contractors. Either insist that they use it or provide QA/QC with robotic total station layout before the pour. Kelly, this is synergistic to your example, find things before the pour. On our projects where we do anchor rod verification, validation, we will use the USIVD's level of accuracy specifications, and we have guidelines for what accuracies are required. It is notable that to get structural steel erection tolerances, you do need to scan at a fairly high level of accuracy. And you want to confirm the anchor rods with scanning before the steel is shipped, ideally. And to learn a lot more about really valuable case studies like this, as a way to avoid problems on projects, I'm going to put in a plug for the BIM Forum. The next session is in November in Dallas, and I'd really encourage people to consider attending. It's a joint conference with the USIVD, and you would learn about a lot of solutions to help avoid these kind of problems on projects.
All righty. Well, thank you, Will. And we did get Buck back, so
Excellent.
Let me see if I can jump back to his slides here. We're going to rewind yours. There we go. All right, Buck, you wanna hop on now?
Yeah. So, sorry about that. I was having a little IT issue, connection issue. The next issue that we ran into, it was actually a really interesting project. The IMAX screen you're seeing in the background is a typical curved IMAX screen. That was not what we were doing with on this project. We were building an ellipses, non-conventional curved IMAX screen inside of a large ride room for a very big client. I think our scope on the project, the entire project, was close to 700 million. The scope on this room was close to 15. Screen and structure and all that was close to $2 million. So if you can imagine sitting in a room when you complete it, sitting down with someone who just gave you, $2 million to make this amazing experience in this room, and the image just starts coming out blurry, skewed. It doesn't look right. It wasn't the best moment for us, at least our team. So we started trying to figure out what was going on, because the screen looks fine in certain areas, and other areas it was blurred, other areas it was skewed. Initially, and if you could jump to the next one, I can show you kind of what we were looking at. The model on the left you're looking at, that's the concrete shell model that was built to support the screen and the bracing. On the one on the right was actually a laser scan we did of that shell. So, the owner and a couple other people said it has to be the concrete. They're outside of their tolerance. The concrete person said, no, we're dead on. They had already done some scanning and some comparison. We went through and scanned it. They were within 1/8 of tolerance all the way. And just the magnitude of this, the diameter at the farthest point was 120 feet. So this is a massive concrete shell. To be within 1/8 was pretty damn good. So we went on and scanned the screen, which was where we found our interesting problem. If you look on the right here, the top, that screen A top edge, it intersected on the sides, and then it deviated out over 6 1/4 inches. And then the bottom edge, if you go to the next one down, was 3 inches out. And then if you go to the very bottom diagram over there, that was in the center of the screen. Everything lined up perfectly. And if you can see the bracing around the back. So what was actually happening was the screen was stretching due to its own weight. We didn't have enough bracing. This was one of the largest curved IMAX screens, probably the most complicated that have been installed. So it kind of came down to how do we assess what's wrong and where that bracing need to be. Through these laser scans, we were able to assess the problem, find better ways to put additional bracing in to support that massive screen. And you know what, we solved the problem. Thinking back to the day that this problem occurred, I think everybody was getting their attorney's phone number out. This was, we had an opening date coming up very rapidly, and this was the one place that they were going to get a lot of attention. I mean, this was where you go when you go to this place to have a great time. And I can't say where it was, but had we not had the capability to be able to go out there and laser skin this, I mean, I don't know how we would have ever solved this other than in litigation, which was besides the point. This is a big owner. This is an owner we go after a lot of work for. And And I don't think anybody, standing around making accusations of whose fault it was, immediately the finger pointing came out. But, when you actually look at these scans, I think everyone had a kind of aha moment as to what was wrong. We were able to change it, fix it, and the screen works great, and we actually did not have any delays. But, that could have been a $500,000 rework. Had we just said, hey, it's the concrete, let's try again, or, the screen's not going to work, or let's go get another screen, not really assessing that it was the weight that was actually creating the problem. Everything turned out great. A lot of people are enjoying this screen in this ride room right now. And I think, as far as dodging it in the future, this is just how we use technology for these really advanced, unique projects. I don't think this is typical. When we talk about concrete, that's not a typical concrete structure. This is not a typical anything. This is a one-of creation on a large scale. And if we didn't have the ability to QC it with laser scanning and actually compare it to our model, we would have been in a lot of trouble. So this is just another example for us, and I think that was a really cool kind of assessment of a problem.
All right. Well, thank you for that, but glad you were able to hop back on. One of the things that I thought was interesting about this job is, it does speak to the fact that, checking these things along the way and documenting the fact that you are in tolerance and meeting the expectations really puts you in a good situation later on down the road to be able to respond quickly and proactively when other things might go a little bit off kilter.
Well, and Kelly, just to say that, David and I were having a conversation, I guess, before we got on here, about proceeding with confidence. A lot of what we do, the old way of doing things was, it's installed right, everything looks right. But if you don't know, you can't really just move forward with confidence. You can't ever just say what we've done is right, let's go on to the next stage. Hit those milestones with the understanding that we're doing what we need to do and we're executing accurately. So I think you're spot on, and I appreciate Career Edge for providing the tools to do that, just from a side standpoint.
Buck, this is Will. One thing you pointed out that really struck me is, you get to an issue like this on a job, and you get to that point where you're concerned that people may be about to call the attorneys. And what I have found is that when attorneys do get involved and insurance gets kicked in, things like laser scanning come out anyways. And, everyone has money to find out later who was at fault. And I think the moral of this story is to encourage owners to start asking for more laser scanning and validation of their designers and builders before you get to these points where attorneys get involved. Because when it does get into litigation, we have been expert consultants on BIM litigation cases, and it always amazes me, people find time to dig into it later when the attorneys get involved. And you're showing a great example of really how to avoid that.
Absolutely.
Spot on. Nobody has it in the budget until the fight comes out, and then it's an unlimited budget to try to figure out who was wrong.
Yeah.
Right.
All righty. So, and I want to take a quick commercial break here to remind our wonderful audience that we do have the intent to kind of go through some issues that you may have come across. So, that can be completely anonymous or as unanonymous as you want. But if you've got, a great story or something like that, go over to the question tool and, type a description and share your story a little bit, and we can queue you up at the end there. And if you don't want to talk about it because you're afraid you might be recognized by your peers, we can always talk about it for you. So by all means, go over to that question tool and dump in some examples. We've got a little bit coming in, but I have a feeling there's more out there just waiting. So, and with that, we will go to our number 2 issue. This one was an interesting one. So this is something, again, we found with some of our early customers on our Verity product, and we thought something must be wrong here because we just couldn't fathom that this was actually a real issue. And after a little bit of investigation, turns out it was. So this kind of comes back to clarity in drawings to some degree. There was a kind of typical structure throughout the building, but there was a level where a column needed to be left out for a piece of equipment, and because of how it was drawn, it was unclear to the subcontractor which level that was. They fabricated everything correctly, but the install went awry, and they just didn't install the column on this floor where it was supposed to be. So you can imagine how fun it is, working with somebody and saying, "Oh, by the way, we think we found a column you're missing." So, in this job, I think ultimately there was an engineering relationship as well with the subcontractor, and they took a fair amount of liberty with the steel installation. Over 70% of the steel was out of tolerance compared to the design. Things installed 12, 18 inches away from where they were supposed to be. In that previous picture, you could also see a lot of the beams were different depths. Now, this was something the subcontractor had some engineering responsibilities to do. Everything was judged to be safe, except, of course, for that lovely column. And that, the column was on the wrong level. The level there was, they actually had installed it in the floor that needed to not have it installed as well. So, there was a fair amount of rework and labor pulling that column out, putting it in the right place. A surprisingly small schedule delay as a result of all this. But I think the big problem there is it created a lot of doubt on that job site as to that subcontractor's capabilities, which probably doesn't bode well for future work. One of the takeaways on this job was just kind of standardizing this kind of post-install testing for structure, and not just doing spot checking, but actually checking 100% of the work. So checking all of the columns, all the beams, all the slabs. This was one of the first people we worked with that after the conversation turned around and went out and bought multiple laser scanners, which are not cheap, but are at least less expensive than they used to be. So this was a pretty interesting one to be on the sidelines for. And with that, can we get David on the line here?
Yes, I'm here.
I just love the fact that we really need Donald Trump to say huge for the impact on this job. So take it away.
Let me start by thanking my old employer, Current Builders, that kind of gave me a job and made my career based on the lessons learned off this first job. So I'm going to be presenting two projects that were really close in scope, value, and share the same design team. I definitely don't want to throw them under the bus. This is why, for everybody that knows me, I am all about lessons learned, and I'd say everybody involved on this project kind of took lessons learned to the maximum extent. And so with all that out of the way, this project happened about 2 years before I entered Current Builders, and the building ultimately was built outside of its project boundaries. You can see from the graphic in the background that it's pretty tightly confined site within the streets around it, and a pretty close neighbor there with a little alleyway in between. The blue markup there represents an easement, a utilities easement going through the entire site, and through a series of process difficulties, we'll put it that way, preceding the world of BIM and really CAD usage in this market, as well as really even PDFs, heavy usage of PDFs on this project. This series of discrepancies led to the project boundary not aligning from the survey to the actual building footprint. And while nobody has actually tracked down and isolated the exact cause of the matter, I think the second project really illuminated a lot of those issues. So Well, this is before my time. I really can't speak to a lot of the detail about it, except that between the redesign, the litigation, the hurricane that hit the project midway through the delay, there was a year-long delay. It cost a lot of people a lot of dollars on all sides, and it cost a client for current builders that really heavily motivated them to investigate other options and really kind of formulated the mantra of what other option do we have but build it wrong. You know, we're not going to build it wrong. We're going to investigate what we can do to learn from our mistakes. So that said, again, I wanted to repeat that luckily everybody did learn from their mistakes, and the design team as well as current builders really developed a really long-lasting, mutually beneficial relationship. The real message on this was better coordination ahead of time, you know, just keeping everybody in the loop. And that coordination really involves your civil engineering team, who often gets on a project, looks at a initial building footprint, does all their work, and then gets off before the design really happens. So if they're not kept back in the loop on the way back, you know, it can really lead to something like this. So that said, let's move on to the next slide. And this is the sister project located nearby. And this is my first job outside of school. So it is also very tightly confined. And through the BIM process, which current builders decided to kind of pioneer, at least in our market down here back in '07, I was just kind of thrown, hey, this is the kind of problems we ran into on this previous job. Let's investigate this one and build it before we build it, kind of attitude. And so I worked very closely with the project team, including my wife and project manager on this. And we ultimately weren't going to do any kind of civil modeling because it really wasn't, there was no civil Revit. So to make a short answer, basic. And so it just so happened that through the course of investigating some grid line discrepancies, we decided to do the property line and found a 5-foot offset of the entire project. This project, the permits had been held for a few years through redesigns, multiple redesigns of the site, and that holding the permit, in order to keep it active, there was some very large foundations for the garage put in place. And actually, before we found the discrepancy, the site had largely been laid out for excavation, and vibroplantation piles had already begun on site when we found it. Luckily, that only resulted in a week or two delay, and we were able to move everything, re-huddle the entire team, come together, and break down a lot of barriers and silos in the process to get the correction in place. Memory serves me correct, probably a 2-week delay in the overall, and ultimately a very minimal impact to the project. There were a series of other issues that all got worked out on the project, but for this happening at the beginning of the downturn of the Great Recession, and some vandalism taking place on the site, we probably would have finished the job about 4 months early. Ultimately, we finished the project 2 months early. So anybody that is looking for a reason to adopt BIM or validation through whatever means, this is definitely a good resource to cite. And ultimately, now with Baker Concrete, we take it to the next level with 3D scanning. So we'll go out to an initial site and 3D scan that site and survey control the 3D scan, survey control the model, and co-locate both of those in various software, and really do the comparison that Verity specializes in ahead of anything being put in place, so that we know not only the existing conditions, but also the kind of impact that we're going to have with the proposed building. So I just wanted to thank everybody at Current Builders for the opportunity to present this.
Yeah, well, thank you for them for sharing it today. And what I loved about this issue is that you kind of see, you know, side by side the impact if you don't catch it, and you know how tiny the impact can be if you do catch it. You know, just minimal delay, some quick adjustments, and you're back up and running. You know, whereas if that thing, you know, lags until after you've got foundations in place, you know, just weeks or a month or two later, you know, the cost can be millions, tens of millions of dollars. Yeah, definitely a kind of a classic case of not, you know, having those discrepancies kind of bring you to a halt. And you know, appreciate sharing the right way to go through it.
Yeah, it was definitely a nick of time kind of situation, and everything, the stars kind of aligned on that project, and ultimately at the end of that one, you know, with the 2-month early delivery, everybody was happy, and it just shows how you can really turn around something using the right tools and getting the right people involved.
Indeed.
And
well,
through the adversity of the first project, we developed some really great relationships, and a lot of people rose to the top of our Current. So, you know, I think we forget that a lot of times by kind of eliminating that or trying to do everything as one person, especially as a BIM manager. You try to, you know, it sometimes is easy to take a lot on by yourself, and it's important to keep everybody involved on your own team.
That's some great advice. And with that, I would like to turn over to a couple audience issues. We're certainly coming up on time here, but we've got a couple here that I think are worth we're having a brief share session. So first, I want to pull up Doug Norton. Can we unmute Doug?
I think you did.
Oh, we did. I think we hear you. So you want to give a quick introduction and then a little, you know, minute or two kind of description of what you ran into?
Sure. We were doing there were two buildings, an as-built renovation and a new building beside it that was a complementary building. And both buildings had elevator shafts in them. And all the dimensions for the elevator shaft and the as-built was from both a scan and the architect's drawings, the design drawings. So that went off pretty much without a hitch. In the new building, however, there was this was a pedestal style construction. So you had a large foundation and then a sort of a platform that the building that's smaller than the foundation walls was built on. This was to accommodate an underground parking garage. So when it came time to do the elevator shaft on the new build, the concrete forming company, because of all of the complicated steps of different elevations on the pedestal, when to lay out the elevator shaft, they went from the outside of the building to the first detail to the next detail to the next detail to the next detail, and then the elevator shaft. Well, the guy must have had a stretchy tape rule or something, because the elevator shaft ended up being 6 inches out of place. If they'd taken if they'd added all the dimensions up, gone from the outside in, they'd have been okay. So this was a creeping tolerance thing. And we didn't have a scanner on site for the as-built situation. So if they had done that, they'd have realized that they were moving the goalposts further and further down the field. And fortunately, when we looked at the tolerances on the drawings, we managed to make everything fit between the elevator shaft and the reference wall. We managed to make everything fit, but it was a very nasty workaround, I'll tell you.
It sounds like it indeed. That's I think the takeaway there is elastic does not make for a great measuring device.
Absolutely. I don't know. He must, as I said, it must have been I don't know what $1 store tape rule he used or something.
Goodness gracious, that's a great one. And Doug, who are you with?
I'm an independent consultant.
All righty. Well, thank you very much for sharing. I think that's a great one. I think we've got Nick Salmons queued up next.
Hello, hello. Hello, USA from the UK. Any chance I could just quickly share my screen with that at all, Kelly? A couple of pictures will paint a million words on this one.
I think we can probably do that.
While they're letting me share my screen, basically back in 2010 when the Olympics were being built in London, we needed to measure the steel frame on the Olympics Aquatic Centre roof, because it was once this should, can we see that?
Indeed we can.
So that's the Olympic Aquatic Centre. Just after we'd done the scanning, during the construction, there's lots of temporary steel to hold the roof up as they progressed across. To get rid of this temporary steel, the whole structure had to be strand jacked from this end by about 2 meters to let the temporary steel be taken away. The measuring how far it settled when they dropped it back off the strand jacks hadn't been considered. The only way we could think of doing it, Balfour Beatty had the job of building the Aquatic Centre. I, with a colleague, 12 hours with 2 scan station 1s at the time, scanned the canopy of the roof to then work out the position of how each node point that Arup, the designers, had calculated in the steel frame. We modelled each steel element in like a cyclone, those of you that use that, and then we manually took an XYZ coordinate of the node of the intersection and put it all into a spreadsheet and handed that over to the engineers, and they then, Arup, the designers rather, they then calculated that the roof had actually settled within tolerance across the whole structure, and that took us, me and a colleague called Harry Parnell, we ended up with eyes like owls after, it took us 30 man days to do that. So that's what we're hoping over in the UK, Balfour Beatty. We haven't got one quite as big as this. We've got several projects coming up that we're hoping to use Verity for to save getting eyes like fish balls. There we go. That it's not really, it wasn't a problem, but it's certainly a solution that Verity will hopefully smash in the future.
Well, thank you for that, Nick. I think that's a great one. Let's see, I'm gonna take back over being presenter here, and then we are going to queue up one last person. Let's see if I can see who that is. Oh, Peter Selix. At first I thought it said Peter Sellers. I was like, what is he doing listening to a webinar? So Peter, you want to introduce yourself and tell us about your experience?
Good evening. My name's Peter Selix. As I actually know Nick, the last speaker, we're actually working on a project together. So quick hello to Nick. I'm with Balfour Beatty as well. Yeah, so I'm currently working on a Ministry of Defence project in the UK, and basically it's quite a simple one really. Number 7, you had some issues with the MEP subcontractors, which is basically seeing very similar sort of issues. The site team, they're a bit old school. They don't really sort of have a lot of faith in the BIM coordination. So their guys are sort of installing elements on site as they sort of see best, really, sort of as they've always done for years. So Nick and his team, they've come sort of scanned our buildings, and sort of we can see exactly sort of how out of tolerance they are. Sort of we're having obviously issues with trying to make sure that we can still sort of meet the client's requirements, and making sure that the as-built models are going to be accurate. So I think the MEP guys, because they did a lot of the design work, now having to sort of spend sort of more money scanning and get their own as-built models up to scratch.
All righty. And you know, that's obviously something you're looking to do more and more on projects in the future.
Yeah, absolutely. Yeah, we're really seeing sort of the power of the laser scanning, and certainly we're looking to have a bit more of a look at Verity and sort of seeing what the verification sort of side of things can can do on it, I think it's going to be a powerful tool, hopefully.
All righty. Well, thank you very much for that. We'll kind of close out here. I know we're past time, so certainly thank you to everyone for sticking with us here. I'm glad we could get to a couple audience examples there. Just you know, to kind of wrap up, we you know, obviously are very interested in construction QA/QC. We'd love to hear more stories, more horror stories. So please, you know, reach out to myself or anybody at the ClearEdge team. If you've got a great field installation issue that you want to share, might do a couple more of these webinars, particularly maybe some for overseas audience that aren't quite as challenging time. And you know, we've come to market to try and solve this problem with the Verity product by providing a tool that will basically, you know, integrate with some common applications that have all the 3D data, compare those things with a high degree of automation, verify the, you know, installation status of all those different elements, fit them together so that we get reports for out of tolerance work. You know, this works for anything. We can do it on pipes, beams, floors, walls, you name it. As long as it scans well, we can compare it. And then we, you know, we are trying to help resolve that as-building problem and making sure that as those discrepancies, which do naturally occur in the field, happen, that there are some really easy tools to quantify and then address those issues. So if anybody is interested in learning more about Verity, of course, please reach out to us as well. You know, reach out to us at our sales team, hop on our website, check out any of the videos that exist on YouTube. And you can see here some of our contact information up on the screen. And with that, thank you all for sticking around. And we will be at a number of conferences in the near future. So, you know, if you're in any of these areas, stop by and see us and say hello. We look forward to talking with you more. Thank you all, and thank you so much to our wonderful panelists. So we can't really do a round of applause since everyone's muted, but you know, Will, Anton, Buck, and David, imagine there are, you know, hundreds of people clapping right now.
Thanks, Kelly.
Thank you guys so much.
Thank you.
Adios.